Looking at this diagram, we see center right here is, the center is going to be some origin. Okay. Positive, we can say positive x is to the right, positive y is up. Each square represents a meter. Person sits at position I for initial and travels the path shown, so along this blue line, to the F for final. The initial position is 4 meters to the left, 1, 2, 3, 4, and 5 meters below the origin, 1, 2, 3, 4, 5. Person's final position is 4 meters to the left, 1, 2, 3, 4, and 3 meters above the origin. However, we can more easily communicate these positions as I equals negative 4m and negative 5m, and F equals those coordinates. In physics, we use positive and negative values to represent direction. The distance this person has traveled, if we count up all of these squares, is 22 meters, so the length of the path is the person traveled. The person's displacement, however, remember displacement is the straight line from the ending point to the starting point, is 8 meters upwards. Other ways to express the displacement: 0 horizontally, 8 meters upwards, 0 horizontally. Obviously, we're not moving to the right or to the left based on our final and initial positions. Back to that delta symbol. We use delta to represent change. We calculate a change by subtraction. That means delta denotes difference. So I want you to remember that every time you see this little triangle, that is delta, and that means change. And change is your final minus your initial. So delta equals final minus the initial. Commit that to memory. Calculate a change in velocity. It's the same thing. That delta symbol just tells us we're going to be doing final minus initial. So it could be a delta temperature, delta T for temperature. So we're going to do the same thing, final minus initial. The initial position in this example is negative 2, 4. The final position here is 2, 1. The displacement of the object is plus 4 minus 3. And you can see that final minus initial. It's this straight line here. So it's this straight line. The object is 4 meters to the right and 3 meters below its initial position. There's your math explanation for you. Reading math is not enjoyable to me, I guess, but also if I'm listening to it, it's hard to see. I can definitely do better with reading it. So take a second, pause it, read. So there we have it, our magnitude of displacement. We know the magnitude of displacement is that. Distance traveled is 17 meters. If we count up all the boxes, we get 17 meters, the length of the path from I to F. The magnitude of the displacement is the straight line distance from start to finish. So remember, magnitude just means how big or how much, is 5 meters, found using the distance formula, or the Pythagorean theorem. A quick shortcut here. Whenever we can find a right triangle, use that right triangle. So that allows us to count up and to the left, and we can figure out the magnitude of that displacement.